Adaptive immunity is awesome. This is a really amazing system that no one could have imagined. No one could have designed this. It's just amazing. I, as a microbiologist, really dig and really appreciate the logic that small cells have to use to navigate the world. Things like quorum sensing are super clever systems that very simple cells can use to do complicated things. And I think adaptive immunity is likewise a really elegant system for doing something truly amazing. It lets us live for 100 years without ever being killed by an infectious disease. And the infectious diseases are caused by pathogens that can run circles around our innate immune systems, but most of them cannot defeat adaptive immunity. So let's get into it. Let's see what it is. It's a big topic. There will be a lot of videos in this series because we have to go pretty slow through the rest of the slides. But by the end of it, I hope you will have an appreciation for how truly amazing this system is. So again, let's compare innate versus adaptive. What I want you to pay most attention to here is how they identify self. Innate immune system actually has receptors for self, and it detects invaders directly using pattern recognition receptors, so it can see non-self. The adaptive immune system is actually blind to self. T cells cannot detect anything self. B cells cannot detect anything self, as you will see. So the adaptive immune system is only able to attack invaders if it's working correctly. And then all this other stuff. The difference in speed, you will see the steps the adaptive immune system has to go through, and you'll see why it is slower than the innate immune system. And then the innate immune system fights off all the random bacteria that fall into you. The adaptive immune system defeats pathogens. It defeats protein toxins. So let's say you get tetanus. Tetanus can kill you, but most people who get tetanus don't die. Most people who get tetanus are very sick for a long time, but then they recover, and that's because their adaptive immune system can actually defeat it. And the adaptive immune system actually takes care of a lot of tumors people have and prevent them from becoming cancer. The innate immune system can do that too, but the adaptive immune system has a really elegant way of doing that. So, these are specific cells we see in adaptive immunity. We see B cells and plasma cells, and T cells, and then dendritic cells, which are themselves innate. They are similar to macrophages, but their job is to work with T cells. And in terms of these lists, you're going to see more detailed lists later on. I've made some very detailed lists of all the cells, and those should help you study. But we'll get to those later. The adaptive immune system has to do certain things. Its challenges include knowing self from non-self, even though it can't use pattern recognition receptors. And it has to win. That's the biggest thing. It has to win against anything. So a totally new bacterium, something that doesn't have peptidoglycan or lipopolysaccharide, probably exists, but your adaptive immune system can still beat it. It has to. And so that's one of its major challenges. Also, it has to remember infections. And the older you get, the more often you have this experience where you start to get sick and you think you're getting a cold, and then you wake up the next day and you're not sick. Well, overnight, your adaptive immune system woke up and said, oh, I've seen this before. Bang, 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 it wins, and you don't get sick. So that's cool. So before we get into the nuts and bolts of what it is and how it works, we will use some terminology a lot. So, terminology we've seen, self. That means, in general, parts of the body that we like. Anything we want to keep. Our epithelial cells, our neurons, our muscle cells, any cell inside us that we want. We don't want to attack. We don't want to kill our own cells. A receptor is a protein that specifically binds one thing. And it does it, again, very specifically. So it only binds one thing, and somehow it can communicate that to the cell. So a receptor is either on the surface of the cell or in a cell, and if it binds the thing it's supposed to bind, somehow it communicates that to the cell. So it gives information to the cell. You're also going to see co-receptors. And these are things that help receptors work. So you'll see co-receptors. You'll see two of them, CD4 and CD8. Think about protein versus carbohydrate. What is a protein a chain of? And what is a carbohydrate? So a carbohydrate is going to be any sugar. It could be a polysaccharide, like a chain of glucose molecules, or a single monosaccharide like glucose or maltose or some other sugars. The reason I bring this up is that your adaptive immune system is very good at seeing proteins and very bad at seeing carbohydrates. So it's usually going to look for proteins. And then antigen presentation is another big thing in adaptive immunity. Antigen is something that causes an immune response. Okay? That's what an antigen is. Epitope is the part of an antigen, the part of an antigen that actually gets detected. So, and that's epitope with an E on the end. Sorry. So, a protein, which is always just a squiggle, because it's a chain of amino acids that is folded up in a really complex three-dimensional shape, and that three-dimensional shape is critical to its function. So, okay, cool. So that's a protein that could be an antigen. Proteins are often antigens. But this part of a protein, and this part of a protein, and this part of the protein, and this part of the protein, and this part of the protein are epitopes. So, while the SARS-CoV-2 virus might infect you, and the spike proteins are antigens, your adaptive immune system doesn't detect spike protein. It detects epitopes. So you have multiple different B cells and T cells that can all detect spike proteins from SARS-CoV-2. And what they do is they detect short little bits of the protein. And that's a very useful thing. And the last thing is display. And the idea here is we have lots of cells that have nuclei, and many of them have a way to show a protein to another cell. And we call that antigen display or antigen presentation. So if that is an antigen, or realistically an epitope, we have several different cells that have ways of displaying that or presenting it to other cells which will examine it using receptors. So this would be a receptor. Okay, so you're going to see a lot of this. You know what? That's enough for right now. In the next video, we're going to cover 3 slides in a lot of detail. So I'll see you there.